And it's time to do our meteorology segment. First thing we're going to look at is the NASA GOES lightning mapper. Why do we show that first? Well, there's a reason behind it. It's because lightning gives us insight into the most extreme portions of a storm. It tells us where the storm's brain is located, let's say, right? So we've got a long line of lightning here stretching all the way from northeastern Arizona up to Lake Michigan and Lake Huron. Pretty much just a straight line of lightning here over the past about 5 hours. And let's check a real-time lightning map from lightningmaps.org, powered by blitzachtung.org. Say it aloud, blitzachtung.org, or if you prefer the Bavarian pronunciation, blitzachtung.org. And let's check it out. We got terrestrial lightning here. Hey, Peoria, there's lightning to your north. Hey, Quincy, there's thunder rolling in. Also, southwest of Kansas City, just to the northwest of Emporia, and to the northeast of Wichita. I use it when I hear thunder. Do you? Leave us your favorite lightningmaps.org story in the comments. Next, pressure maps. Here are pressure maps on windy.com. We'll let this advance into tomorrow. This is the European forecast for pressure. And we'll pause this at around 12 noon tomorrow. And there's where we expect things to be according to the European forecast at 12 noon. That's Eastern Daylight Time. Next, looking at nullschool.net's 250 hectopascal winds, a.k.a. the jet stream. Northern Hemisphere jet stream still looking extremely chaotic and broken up. It's all over the place. Southern Hemisphere jet stream a little bit more coherent. Let's check surface winds. There are the surface winds. Strong winds here still in the Southern Ocean, as well as off the west coast of India. Here are the surface winds of the Western world. And we've got a strong system out here several hundred miles off the coast of Mexico. Here's the jet stream scenario for the western portion of planet Earth, and check out how chaotic the Northern Hemisphere jet stream remains. Extreme meridional jet stream flow conditions. And it looks like some cold days happening in Greenland. By the way, if you didn't watch yesterday's meteorology segment, go check it out. You can find all of our videos on our playlists. We put practically every video we ever make on a playlist. And if you want to see the whole list, go to youtube.com/smashamash/videos. And if you're watching on BitChute, make sure you subscribe on YouTube. No matter how much you hate Google, most of our content is there, and we need your assistance. We get hundreds more views on BitChute per day than we get on YouTube. So tell your friends, foes, science noobs, and science pros about the channel. There's the weather.gov map, and let me just pause for a moment to check the life of the stream. Also, thanks for leaving a comment. Robert, good morning to you as well. And the stream looks just fine. Let's continue on here at the Smash News Network, least busted name of news, to thank our patrons. If you haven't become a patron, please consider doing so at patreon.com/smashomash. You get all kinds of early alerts, multimedia, and more. You also get the opportunity to be in our videos, be behind the scenes, and so on. As our capabilities increase, there's all kinds of stuff going on behind the scenes, thanks to Smash staff as well. Oh, she's a patron. Who knew? No, I'm just kidding, folks. It's part of her job is to be a patron. For quality control purposes, thanks again, patrons. Patreon.com/smashomash. Let's take a look at the U.S. Doppler radar scenario. And there's the vertical motion in the air column, which is what Doppler radar is. That's why it's called Doppler radar. When you hear Doppler, we're talking about motion. Anyway, not a lot to comment on there. Let me just refresh our water vapor and our cloud cover maps. And we are streaming live. It's the dangers of streaming live, folks. Sometimes you have to press refresh. So anyway, there's the U.S. Doppler radar. There's the cloud layer. And there's the water vapor map. And basically the reason all this moisture is constrained to this area is because of this dry massive air. These are effectively high pressure systems, at least comparatively speaking, to this low pressure system in between. And it's constraining all of that weather into that area. That's why we have that long line of lightning, as we've got massive pressure gradients where that dry massive air meets up with that much lower pressure, less massive watery air. Yes, wet air. High humidity regions are less dense than atmospheric nitrogen because H2O is less massive than N2. That's all. Anyway, once again, there's the U.S. Doppler. There's the cloud layer. And there's the U.S. water vapor map. Thanks for tuning in to today's meteorology segment. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted. Name it news.